Hello friends, welcome to my channel again. In today's session we are going to take some information about deadlock as well as the necessary conditions which may cause deadlock in the distributed system. Normally when we say that distributed system, it contains processes and resources. If I have two processes with me, P1 and P2 are my two processes, and these processes are using couple of resources. This is R1, resource number 1, and resource number 2. Process P1 wants resource R1, but resource R1 is already allocated to process P2. Process P2 wants resource R2, but resource R2 is already allocated to process P1. But now the situation is that process P1 is waiting for resource R1 and process P2 is waiting for resource R2. Now both of these processes P1 and P2 are dependent on each other. If this is the situation, then the system will go into deadlock. A complete loop will get formed between the processes and the resources. One process will be dependent on another process to release the resource. In this case, P1 is dependent on process P2 so that P2 will release the resource R1. Similarly, P2 is dependent on process P1 because P1 process is holding resource R2. Until and unless P1 releases the resource R2, P2 will not be able to utilize that resource. So this is the problem, and this results into a deadlock. Normally the interesting thing is in distributed environment, multiple sites are there. Suppose we can say that site number 1, site number 2, and there are site number 3. Every site is having some resources associated with it, and every site will execute some processes on it. So these three sites are there which will contain processes as well as resources. So every site will contain processes and resources. The processes of site 1 may require the resource from site 2, and the processes from site 2 may require the resource which are residing on site 3. Processes at site 3 may require the resource which are situated on site 1. Probably in this case a circular wait may get arised, and that circular wait between the process and resources will result into a deadlock. So this is what the concept of deadlock. Now let's go ahead. Now we will discuss the necessary conditions of occurring the deadlock. Basically there are four necessary conditions. First one is mutual exclusion. In mutual exclusion, two or more processes must be competing for a common resource that cannot be used simultaneously. Suppose I have process P1, P2 and P3 running in the distributed environment on different sites. One common resource is there. We will call it as resource R. Suppose we will say that this resource is a memory and every process wants to access that memory. If the access to that memory is allowed to every process, then probably process P1 may write some data inside the memory, process P2, P3 may reading the data from the memory, process P2 is also writing some data on the same memory. So there will be chances that some conflict may get occurred. Suppose we will consider the case, this memory is holding the value 10, process P1 is using that value 10 for doing some calculations. Process P2 has done some calculation and it has to update the value, and process P3 is interested into the old value, that is what 10. Now the thing is that if process P2 has done some calculation and updated the value to 100, then process P3 might get incorrect value. So our intention is we need to limit the access to the shared resource. So this limiting the access to the shared resource is achieved with the help of mutual exclusion. Second condition is hold and wait. Hold and wait condition tells that one process must be holding a resource and waiting for another resource which is held by some other process. Suppose process P1 is there which is holding a resource R1 and process P1 is waiting for the resource R2. But here R2 is held by another process known as process P2. So this is what hold and wait condition. In this case one process must be holding a resource, that is what process P1 is holding resource R1 and waiting for another resource, that is what resource R2, which is again held by process P2. This is what hold and wait condition. Let's move ahead. Now we will study the third condition which is called as no preemption. In this case, the distributed system will not be able to preempt one process and give that resource to another process. It means that if we consider the earlier example, resource R2 is held by process P2, but resource R2 is required by process P1. Process P1 wants resource R2. Now the thing is that distributed system must not be able to preempt one process and give the resource to other process. So here will not be able to preempt process P2 and give the resource to process P1. The last condition is circular wait. Here we can say that a circular wait must exist where process A is waiting for resource held by process B and process B is waiting for the resource held by process A. For example, suppose process A is there and process B is there. Process B is holding a resource R2 which is requested by process A, and resource R1 is already occupied by process A and process B is interested into resource R1. So this type of circular wait exists, so that may take your system into deadlock. So these are the 4 conditions which may take your system into deadlock. So we can say that when all 4 conditions exists at a time, so we can say that our distributed system will enter into the deadlock phase. Here we can say that when all these 4 conditions will take place simultaneously, then there are chances that distributed system will enter into deadlock. For coming out of the deadlock, at least one of the conditions should not get satisfied. That's it from this video. If you are having any queries, any questions about this topic, please put it in the comment box. I will try to answer these questions as early as possible. Thank you for watching the video. Please press like button and subscribe to my channel. Don't forget to share this video with your friends.